Welcome to video number 4 in my Build Your Own AI series. Given Melbourne has re-entered lockdown restrictions, this has become my isolation project and I'm getting things done quite quickly. Let's walk through the changes I've made and the latest code posted to GitHub. Firstly, I've renamed the folder where libraries of code are stored for the client and Brain. The folder is now called lib rather than client, as it holds code for both our client and Brain scripts. I've also moved some code that was common to both the Brain script and client script into a file called common utils. This gives me a single place to make changes for common code if needed. In my architecture planning video, I mentioned the current context would be stored on the Brain in a JSON document. In my Brain script, I am setting context in a dictionary object called environ. Note that in Python, a dictionary object is the equivalent of a JSON document. In our client script, we are setting up a similar object with default values. But when we connect to the message queue, I want the Brain to overwrite these. So now we've added some code so when the Brain detects a connection message from the client, it will respond by pushing the environ data back down to the client, and when the client receives that corresponding message, it will update its local copy of the environ data. Eventually we will need a mechanism to continuously do this, so that if I tell a device in my garage, for example, to turn on secure mode, all client devices will be notified of this. So in reviewing what we have built so far, when our client device connects to the message queue, it sends a connect message in JSON format. The Brain sends back the current environment settings in JSON via the message queue, and the client updates its own settings. We also have a motion sensor which runs on our client, and on detecting motion sends an image to our Brain via the queue. The Brain detects objects in the image and sends back a JSON response via the queue. And now we are going to develop some logic for the client to respond to those results. This pattern of 3 files matches our pattern from the architecture discussion of sensors, feeding the Brain, and some action being the result. In our case, sensor logic runs on the client, sends input to the Brain, which results in an action back on the client. When we come to do our chat logic, it will follow a similar pattern with these 3 similar files, but substitute the word motion for perhaps voice or chat. So what do we want our client to do once the image is analyzed? Let's start by simply saying hello there if a person is detected, and if a person is not detected, we'll say nothing. Before we create our client action file for motion, we are going to need to install a text-to-speech application. There are several available for Linux, such as eSpeak and Flight, but the best one I've found so far is called Pico2Wave, and we can install it with the command shown here. If we run Pico2Wave at the command line, you can see how to use this application. It produces a WAV file as an output, so to actually hear the words spoken, we would need to then play the resulting WAV file. But with the magic of Python, we can stream the result to an in-memory temporary file and play that file. This is faster as it saves writing to disk. Multiple components on our client will need the power of speech, so I've wrapped the necessary commands into a class object named voice, which we can then pass to our logic as necessary. Let's now add the necessary import statement to load the new class into our client script file. We will then create a reference to the class object down below here where we define our variables. And then we can pass that class object into our function, our action script. And to do that, we need to replace this text here where we're just doing the printout with something similar to what we did in the Brain script. So let's copy that across. And we can reference our file that we're about to create, being the client action file for motion. Now we're going to be leveraging the new library of voice functions in our client action file. So let's actually pass that across as a reference when we call that file, and then we can start to actually create that logic. After a bit of testing, I found that the JSON text pulled down from the message queue by my Raspberry Pi was actually binary, not text. So I had to add this to convert to a UTF-8 string. And this is the logic that will be run when we receive our image analysis back from the Brain. Firstly, we set up logging. We then load the response into a dictionary. We get our 2 motion-related settings from the environment. We check if a person was actually detected, and then we respond accordingly. So let's now test with our Raspberry Pi running the client script. I have the Brain script running on my laptop, and I've attached my Pi to a TV via the HDMI cable, so I have some sound.
Hello there.
Despite the background noise, you can clearly hear our client motion logic being triggered and our robot voice responding. In the next video, we are going to look into how to make our artificial intelligence more chatty. If you want to be notified of when the video is available, then please subscribe, and thank you for watching.